Today we're going to continue talking about solving trigonometric equations, but this time we're going to look at solving them in the quadratic form. All quadratic equations have a similar form, and trig equations are no different for that. So trig equations can be in the quadratic form of ax squared plus bx plus c. To solve equations of this type, we factor the quadratic, or if this isn't possible, we'll use the quadratic equation. To recall, the quadratic equation is negative b plus or minus the square root b squared minus 4ac all over 2a. So let's look at some examples on the interval 0 to 2 pi. Let's look at the first one. You can see that there are only two elements in this equation, and they both have a similar element, cosine. So you can factor out a cosine of x, leaving you with cosine of x times cosine of x plus 1 equals 0. Then you'll set each of those equal to 0, so cosine of x equals 0, and cosine of x plus 1 equals 0. So then you'll subtract 1 just like you would for a normal solving of an equation, and you're left with cosine of x equals negative 1 and cosine of x equals 0. So for cosine of x equals negative 1, x equals pi, and x equals negative pi. And those are the only two solutions for that equation since they're in between 0 and 2 pi. And then cosine of x equals 0, x equals pi over 2, and x equals negative pi over 2. So now let's look at 2 sine of x squared minus sine of x minus 1. This equation has three terms, so we're going to factor it using the two parentheses. So you'll factor these just like you would for a normal quadratic, except you'll put a sine of x on both of them. The first one will have a 2 since it has a coefficient of 2. So then we'll look at the last term. The last term is 1, and so that can only be divided into 1, and you'll put 1 on either side. Then you'll look at the sign that's in front of the 1. It's a minus sign. So you'll put a minus with the larger of the two when you do the outside and inside part. So the plus will go with the 2 sine of x plus 1, and then the minus will go with sine of x minus 1. So then you have 2 sine of x plus 1 equals 0, and sine of x minus 1 equals 0. So 2 sine of x plus 1, you'll subtract 1 from both sides, and you're left with 2 sine of x equals negative 1, divide by 2, and then you have sine of x equals negative 1/2. So then you can use your unit circle to find that sine of x equals negative 1/2 at 7 pi over 6 and at 11 pi over 6. So then let's look at sine of x minus 1. Then you'll add 1 to either side, and you're left with sine of x equals 1. Then you're left with x equals pi over 2. So let's look at two more equations that are on the interval 0 to 2 pi. The first one is secant squared x minus 3 secant x plus 2. So you can see there are three elements in this, so you'll factor it with parentheses like we did for the last one. You'll put a secant at the beginning of each. Then 2 can only be factored one way, and you can put a 2 at one parentheses and then a 1 in the other. And then you'll look at the plus sign in front of 2, and that means both symbols will be the same, so they're both a minus. Then you can set secant of x minus 1 equals 0, and secant of x minus 2 equals 0. So looking at secant of x minus 1, you'll add 1 to both sides. Then you'll have secant of x equals 1. So you can change secant of x to 1 over cosine, or just find where cosine of x equals 1. But then if you do it this way, you'll multiply by cosine on either side, and then you're left with cosine of x equals 1. And cosine of x equals 1 at 0. So let's look at secant of x minus 2 equals 0. So you'll add 2 to both sides, leaving you with secant of x equals 2. So here we'll change secant of x to 1 over cosine of x again, and then multiply cosine on either side. And then you're left with 1 equals 2 times cosine of x, and you'll divide by 2, and then you have cosine of x equals 1/2. So you have x equals pi over 3, and x equals 5 pi over 3. So now let's look at sine of x cubed equals sine of x. So there are only 2 elements in this equation, but they're on the opposite side of the equal sign, so you need to put them together. You'll divide one side by sine of x and the other side by sine of x as well, leaving you with sine of x squared equals 1. So now we're going to move the 1 over to the other side, so leaving you with sine of x squared minus 1 equals 0. This is a perfect square, so you'll do 2 parentheses with sine of x plus 1 and sine of x minus 1. So you'll set them both equal to 0, leaving you with sine of x minus 1 equals 0. So then you'll solve for that and add 1 to either side, leaving you with sine of x equals 1. So now let's look at sine of x plus 1 equals 0. You'll subtract 1 from both sides, leaving you with sine of x equals negative 1. And let's go back and look at sine of x equals 1. We know that sine of x equals 1 at x equals pi over 2. And now we'll look at sine of x equals negative 1. So sine of x equals negative 1 at x equals negative pi over 2. And those are your 2 solutions for this equation. So let's look at another equation on the interval 0 to 2 pi. When working with a quadratic function, be sure the equation involves a single trigonometric equation. So number 5 has 2 trig equations in them. Since you can only have one trig function in any equation, we'll have to change one of the ones in here. So sine of x squared should look like an identity that you've seen before. This can equal 1 minus cosine squared of x. So let's plug 1 minus cosine of x squared in for sine of x squared, leaving you with 1 minus cosine of x squared plus 2 cosine of x minus 4 equals 0. So let's combine the 1 and the negative 4, and then you're left with negative cosine squared of x plus 2 cosine of x minus 3 equals 0. But we don't want to have a negative first term. So we're going to multiply both sides of the equation by negative 1 to change the signs. So since that changed the sign and everything, now we have cosine of x squared minus 2 cosine of x plus 3 equals 0, since 0 times negative 1 is still 0. So now we'll factor this like we've been factoring the others. We'll put the 2 parentheses and put a cosine of x in one and a cosine of x in the other. And then the only way you can divide 3 is by putting it as 3 and 1. So you'll put a 3 in one side and a 1 on the other. And then you'll look at the sign before the 3. It's a plus sign, so you know that both parentheses will have the same sign in the middle. And then we're left with cosine of x minus 1 equals 0, and you'll add 1 to both sides, leaving you with cosine of x equals 1. So then you know that cosine of x equals 1 at x equals 0 and 2 pi. But if you look at the directions, it says on the interval 0 to 2 pi, and that's a closed parentheses there. So 2 pi is not in the interval, so 2 pi is not a solution to the equation. And now let's look at cosine of x minus 3. So you'll add 3 to both sides, leaving you with cosine of x equals 3. Notice that there's nothing on the unit circle that makes cosine of x equal to 3. So we'll have to use the inverse to find it. The inverse is arc cosine, so you'll take the arc cosine of both sides, and then that gives you arc cosine of 3 equals x. Although you found 2 solutions to the equation, since you changed the original, you need to check and make sure that both solutions work. So plug in 0 for x on both, and then plug in arc cosine for x on both. If you plug in 0, you get -2 as the solution, and if you plug in arc cosine of 3, you get -6, which means neither of those are solutions that work for the equation. Now let's look at our final example on the interval 0 to 2 pi. This one is 2 secant squared of x plus tangent squared of x minus 3. Just like the last one, in order to solve, you can only have one type of trig function in each equation. And this one has 2. So we'll have to use trig identities to get it back to 1. Secant of x squared has a trig identity of 1 plus tangent squared, so we're going to plug that in for secant squared of x. So the equation is now 2 times 1 plus tangent squared of x plus tangent squared of x minus 3 equals 0. Then we're going to distribute the 2, and so now we have 2 plus 2 tangent squared of x plus tangent squared of x minus 3 equals 0. So let's combine the 2 and -3, and now we're left with 2 tangent squared of x plus tangent squared minus 1. Once again, we're going to combine like terms and combine the 2 tangent squareds, and we're left with 3 tangent squared of x minus 1 equals 0. And we'll add 1 to both sides, and then we have 3 tangent squared of x equals 1. We'll divide that by 3. Now we have tangent squared of x equals 1 over 3. And we'll take the square root of both sides, leaving us with tangent of x equals square root of 1 over square root of 3. And we can't have a square root on the bottom, so we'll have to rationalize with the fancy one. So we'll multiply by the square root of 3 on the top and on the bottom. And then we have tangent of x equals square root of 3 over 3. Again, from the unit circle, we know that tangent of x equals square root of 3 over 3 at x equals pi over 6 and x equals 7 pi over 6. Since we changed the equation at the beginning, we have to check to make sure that both of the solutions work. So once you plug in pi over 6 and 7 pi over 6 in for x, you'll realize that both solutions work, so they are solutions to the equation.